Plus or minus 2.
So I'm hearing some votes.
Plus 2, 5.
One of our stats, let's figure it out.
So that's where that range came from.
Just make sure when you do one of our stats, you also tell it L1 and L2. This is crucial. If you don't tell it L1 and L2, it's going to give you an answer. It's also going to be wrong. Most probably, at least part of it will be wrong. Because if you just do one of our stats without the frequencies, it thinks there are only 9 people voting, and that's wrong. There are more than 9. So when you run your one bar stats, and this is pretty important, tell it L1, L2. L1, L2. That way the data in L1 is weighted with the frequencies in L2, and we're much happier that way. All right, now, notice the average is fairly close to what it was. That's because the data is a certain shape, which it often is when people try to guess the weight. So on average, you guys guessed right around 165 pounds. Yep. So my average weight, according to you guys, is about 165 pounds. Now, of course, that average also has a standard deviation, which you guys plus or minus 10 pounds. Plus or minus 10 pounds. And again, please interpret what that 10 means. Let me see hands on this. Let me see hands on this. Interpret what that, this is good practice if you got this wrong on the exam for the redo. What does that 10 mean? Standard deviation is 10. I mean, yeah, plus or minus 10, but that only, the plus or minus bit can only be used in certain cases. But you can always define the standard deviation as, Jen, go ahead, be brave.
Standard on the average distance from the mean.
On average, you guys guessed 10 pounds away from the 165. On average. Some of you guessed right at 165. Looks like one of you did, I think, if I'm reading that right. No, 6 of you did. 6 of you did, yes. 6 of you guessed right at, so you guys are 0 away. But some of you guessed 20 pounds off. 145, 185, those are 20 pounds off. And if you look at all those distances and average all of them together, it averages out to 10. So the plus or minus of 10 just is the idea that you guys were off on average by 10 pounds from your average that you guessed at 165. Fair enough? That's all that means. That's all that means. Okay, good. Now, say that again. You do. Say that again. Is that you, Zach? Yeah. Say it again.
Average from average.
It's the average distance from average. You have to use the word average twice. I mean, you do. You have to. Some of you get away from it by using the word mean instead of the second average is on average distance from the mean. But I mean, the mean is just another word for an average, so you're still saying the same thing. Still correct the same thing, too. Good. We got a median down here? Yep, median's 165 as well. Median's close, so tight. Median's close to the average, and to the nearest pound. Yeah, to the nearest pound. Kelly, go ahead.
Well, I thought we were going to figure out how to put that in our absolute value.
We were, say that again.
I can't get the comma.
It's above the number 7. It's got its own key. Above 7?
Yeah, but when I push it, something else, a J comes up.
You're in alpha mode. Don't press any button before the comma. A J? Yeah, J would be alpha comma. You don't want to hit the alpha button. Here, let me shake it. Shake it. Oh, you're doing a graph. No, in the graph, you put L2 down here. Yeah, you're going for the histogram, which I was going to next anyway.
Okay.
So Kelly's going for a histogram now, which I think we should also look at. Because if the data is, if it's bell-shaped, then we can actually add and subtract standard deviations, talk about percentages, yes? Yes. So I'm going to go ahead and set the histogram up, plot 1. This is where you were, Kelly. The comma is in the 1-bar stats. I don't know why they made it different for these two, but they did. It's unfortunate, but. So here we go, set up, zoom, 9, there it is. I'm gonna mess with the scales a little bit to make it a little more unified. 145 is a fine min, that's what the lowest one was. X max, I'm gonna make 190, just because that's 5 above the 185. This answers Lydia's question again as to we have to give it that extra room for that extra bar. I'm gonna make the scale 5, because 5 pounds seems the most logical increment, since you were guessing in 5-pound increments. And then I'm going to hit graph. And there it is. Looks like you guys guessed roughly in A. I would call that a bell shape, would you? You can say no. Good. For those of you that say no, we'll come back and develop another way to identify outliers. There's 2 ways I want to talk about today to identify outliers. One of them is if you have bell-shaped data, and one of them is if you have any kind of shape of data. Darn, ask me that question. Or you just Okay, I thought you did. I thought I saw your face change. Sorry, like an amphibian. I see motion. I'm going to call this roughly bell-shaped. I know it's got holes in it, but I mean, I'm still seeing essentially a hump in the middle and some tails going off to the side. So I'm going to go ahead and call this a bell-shape. That's just me. You can say no, and there is a fallback if you don't think it's bell-shaped enough. You can always calculate its skew if you want to do that. I'm not going to make you do that, though. I'm going to say ballpark. I'm going to call that a bell. You don't have to. If you have bell-shaped data, I'll slide over here. Here is the standard accepted rule for outliers.